All right, so we're going to continue on with finding angles and sides of triangles that aren't right triangles. And yesterday we did something called the law of sines, and today we're going to do something called the law of cosines. It's just a way to find sides and angles of triangles that aren't right triangles. And it depends on what information you're given. So for the law of sines yesterday, you could have been given angle side, you could have been given an angle side angle, or you could have been given an angle side side, or side side angle, however you remember it. For the law of cosines, which is what we're going to do today, it works when you're given all three sides, so a side, 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 or when you're given a side angle side. So just you have to know what you're looking for, and when you see one of these patterns you recognize, that lets you know which law you're going to use. So again, I'm going to do a little algebra here to let you see how the law of cosines works or where it comes from. And again, I'm going to divide this triangle so that I come up with two right triangles. So I'm going to split it like that, and I'm going to label all the sides now that I've made in these two little right triangles. So this is H for the height, and it'll be the height of both right triangles. And for this little one over here, this bottom base of it will be X, and the bottom base of this one will be Y. And the C we'll worry about in a minute. But for now, if you just look at this triangle right here, the big one here, you should see that H squared plus Y squared equals A squared. So I'm going to write that down. H squared plus Y squared equals A squared. And with that same logic, if I look over at this little triangle here, I should see that H squared plus X squared equals B squared. So I'm going to write H squared plus X squared equals B squared. Okay, and I'm going to start working with this one over here, just this one on the left side. I'm going to manipulate it a little bit. So I'm going to write H squared plus, and instead of Y, I'm going to look back up at my picture. Y is equal to whatever C is minus X. So if I had C and I took away X, Y is what would be left. So instead of Y, I'm going to write C minus X squared equals A squared. And I'm just going to do a little algebra here. Okay, I'm going to write H squared plus, and I'm going to FOIL this. So I'm going to do first outside, inside, last. And I'm going to get C squared minus 2cx plus x squared equals A squared. Now I'm going to just move it around. I'm not going to do any more algebra. I'm just going to relocate. I'll put this x squared over here. So I'm going to write x squared, h squared plus x squared plus c squared minus 2cx equals a squared. Now if you'll notice, it may seem like I'm just randomly doing algebra stuff, not really headed anywhere. I've got h squared plus x squared right here. Well, in this same big triangle that I have, h squared plus x squared is equal to b squared. So I'm going to substitute b squared anywhere I have an h squared plus x squared. The reason I'm doing that is because I added these x's and y's and h's to this problem. You're not going to be able to do that in a real world problem. You're going to have to be able to work with only what's given to you. So I need to manipulate all of this, get rid of all these x's and h's and y's, and have nothing but a's and b's and c's, and be able to use just that information to find all these missing angles. So just stay with me for a little bit longer. You're not going to be expected to do this from scratch or anything like that on your own. So h squared plus x squared gets replaced with b squared plus c squared, and still minus 2cx equals a squared. Well, now if I look back up at my triangle here, and I look at this one on the left, the cosine of angle A, remember cosine is adjacent, over hypotenuse, right? So the cosine of angle A is adjacent over hypotenuse. So the cosine of angle A equals adjacent over hypotenuse. So I could multiply both sides by B, and I'm sure you're thinking to yourself, Mr. Lewis, I have no idea why we're still doing this. But don't worry, it'll make sense in a minute, hopefully. So now I have the B times the cosine of A. So B times the cosine of A equals X. So instead of X, I can just write B cosine A. I know you're probably thinking, wow, that's awesome. Thanks for telling us that. So B squared plus C squared minus 2. Now, C is still there, and instead of X, I'm going to write B cosine A equals A squared. And the only thing I need to clean up here about this is that I have the C and the B in non-alphabetical order. It's not that big a deal. I'm just going to rewrite it. B squared plus C squared minus 2BC cosine A equals A squared. And this is the law of cosines. Now, all I did was manipulate this one, right? Which basically just dealt with side A. I could have done exactly what I did here, but done it with this one and just dealt with side B, or I could have done it with side C. So there's 3 law of cosine formulas that you're going to have to know. I'm going to write them all right here. The first one says that A squared equals B squared plus C squared minus 2BC cosine A. The next one is B squared equals A squared plus C squared minus 2AC cosine B. And the last one is C squared equals A squared plus B squared minus 2AB cosine C. Right? These are called the law of cosines. Okay, and just like the law of sines, we're going to have to memorize them. Okay, so these would be the kind of thing you might want to throw on some flashcards. But they're not that hard to remember. Okay, what you should see is that the one that starts with an A ends with an A. The one that starts with a B ends with a B. The one that starts with a C ends with a C. And the sides that are used in the equations, so for the A equation, only uses the B and the C in the other 2 spots. So the one that uses the B only uses the A and the C in the middle of the equation, and the one that uses the C only uses the A and the B in its equation. So, like I said, it only works when you're given a side, 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 or a side angle side. We'll take a look at both scenarios real quick. So we'll do the SAS, or the side angle side scenario first. So side angle side, we're going to have a triangle. It'll be triangle ABC. And in triangle ABC, we're going to know that the distance from A to C is 9. The measurement of angle A is 62 degrees, and AB is 14. So you should see here that we have an SAS, side angle side pattern. And our job is going to be to find segment BC. So we're going to find this third side here. Well, if you remember, look back up at the law of cosines. Whichever side you're trying to find, you're going to have to know the other 2 sides and then use the cosine of the angle that's opposite of that side. So we go back down and look to find BC. Right, if we want to find BC, we'll do BC squared equals, now we're going to use the other 2 sides, so AB squared plus AC squared, and it's going to be minus 2 times both of the sides again, so AB times AC, and then times the cosine of the angle that's opposite of BC, which is the only angle we know, angle A. So BC squared equals, AB is 14 squared plus 9 squared minus 2 times 14 times 9 times the cosine of 62. Not so bad, just calculator stuff. So BC squared equals 14 squared plus 9 squared is 196 plus 81, which is 277, minus 2 times 14, that's 28, times 9 is negative 252, or minus 252, cosine 62. You type all of this in your calculator in one step, and you get that BC squared equals 158.69. Now, that's an approximate estimate, and we're going to approximate it even more because we're going to take the square root of both sides, and that'll tell us what BC by itself is approximately equal to. And when you square root 158.69, you find that it is very close to 12.6. So that's how the law of cosines will help you find the third side of a triangle when you already know a side angle side in that triangle. Now we're going to go down and do the last kind, which is when you're given an SSS, all three sides. So we're going to draw a triangle with all three sides. It's going to be triangle RST. Okay, and in triangle RST, we're going to say that RS is 4, ST is 9, and RT is 7. So obviously, we're not going to be able to find another side length because we already know all three. So the SSS version is always going to be used to find a missing angle. And for us, we're going to find, but we could find any of them, we're going to find the measure of angle R. Okay, so that is this angle right here. So that tells me if that's the angle I want to find, I'm going to use the law of cosines formula that starts with the side opposite of the angle I need. So I'm going to write ST squared equals SR squared plus RT squared minus 2SR times RT, and then cosine of the angle that I'm looking for, angle R. I promise this will get better. I'm going to fill in everything I know now. I know that ST is 9 squared equals 4 squared plus 7 squared minus 2 times 4 times 7 cosine R, because I don't know R. So I know this is 81 is equal to, now 4 squared, 16, plus 7 squared, 49, is 65, minus 2 times 4 is 8, times 7 is 56, cosine R. So I want to solve this, and I want to find out what R is, so I needed to say cosine R equals. So I'm going to subtract 65 from both sides, get 16 equals negative 56 cosine R. I'm going to divide both sides by negative 56. 16 divided by negative 56 is negative 0.286, and that's equal to cosine of R. So to find R, I'm going to do cosine to the minus 1, the inverse cosine of negative 0.286. See what that equals. Type it on my calculator, and it equals 106.6. So that means the measure of angle R is 106.6 degrees. And that's approximately 106.6. So that's the law of cosines. It may not seem as friendly to you as the law of sines was. So if you really struggled with the law of sines, you're probably ready to punch your fist through your computer right now looking at this. But it will get better. It's just a pattern, and once you've done enough of them, it'll be one of those things that you can never forget. So write down any questions you have and bring them with you tomorrow.